The nose and disease. If you are ambitious to find a new science, measure a smell. Alexander Graham Bell. The five senses: sight, touch, taste, sound, and smell. Smell. You can smell food, markers, grass, etc. And you can smell body odor. The human body smells the way it does due to the presence of volatile organic compounds that have a distinct smell, which combine to give a person their smell. However, disease can change that smell. The levels of microbes in one's body are changed due to disease. These microbes often have specific odors. Therefore, one's body odor may change due to the presence of disease. In fact, some diseases are said to have distinct smells. For example, typhoid is said to smell of baked bread, scurvy of putrid sweat, cholera of sweet-smelling feces, pneumonia of foul breath, arsenic poisoning, a garlicky body odor, phenylketonuria, a musty sweat and urine. Others, such as yellow fever, are said to smell of a butcher's shop, and diabetes of a fruity urine and breath. However, the idea of being able to identify diseases through scent is not a novel one. The Sanskrit text, the Sushruta Samhita, decrees, by the sense of smell, we can recognize the peculiar perspiration of many diseases, which has an important bearing on their identification. Certain animals, such as dogs that have remarkable olfaction or sense of smell, have been trained to detect certain diseases in individuals. However, this is time-consuming, expensive, and unreliable, as olfaction of animals can change among individuals and even in the individual itself. More recently, pursuits of creating artificial olfaction sensors or electronic noses are being made. Here, sensors change as they come into contact with certain chemicals. These changes are recorded and cross-referenced with existing samples. However, problems that exist with this method is that sensors may not be sensitive enough to detect the vast array and composition and proportions of chemicals in each sample to be extremely accurate. With the growing practicality of artificial intelligence, it is worth considering the possibilities of training neural networks to function in a manner that can more effectively use vast amounts of data while adapting to feedback to more efficiently identify health markers. In this way, one's health status may be more efficiently and effectively gathered and determined. Other implications of diseases having a distinct smell, meaning that they have distinct chemical makeups, leads to the notion that this makeup can be detected, perhaps in a more basic way, through chemistry. Many impoverished nations suffering high rates of disease in the population may largely benefit from affordable and accessible disease detection, as many possibilities discussed previously are often too expensive or impractical. We should look to more accessible technology. In knowing the chemical makeup of a certain disease, can we not consider the possibility of detecting the presence of key chemical compounds present in key levels which indicate the presence of disease? Much like litmus paper utilizes a chemical reaction between molecules present in the strip and molecules possibly present in the substance being tested, with a change in color of the strip indicating the presence of an acid or base depending on the strip you use, and similarly, how pH paper is coated with various indicators that are activated with varying levels of the substances being tested for, one could potentially check for the presence of a chemical in a certain proportion to the rest of the sample of body odor. Along with the presence of multiple detectors, each reacting with one chemical characteristic of a certain disease or diseases, all aligned in compartments along one test strip, it may be possible to use the resulting signature of one's body odor compared with the legend of the chemical fingerprints of various diseases to identify the presence of a particular disease. This could be particularly useful considering situations such as the ravaging presence of malaria in many African countries, where affordability and accessibility may be key to detection of the disease, as the medical resources and technology as well as the financial resources may not be widely available to both doctors and patients. A strip designed to detect the presence of malaria, specifically to detect chemical compounds specific to the disease in certain levels, through the ability to react with each compound, a different detector for each chemical all along the strip, resulting in one fingerprint that can be checked to confirm or deny the presence of malaria, using a key devoid of language barriers, can save lives. However, some possible considerations include identifying the proportions of chemicals that indicate illnesses, individual anomalies that do not comply with the conventional chemical change a disease may cause, rendering the detector ineffective in identifying the disease, the specificity and sensitivity of the detector in being able to detect trace amounts of certain chemicals, and the complexity in including detectors for the sometimes large amount of chemicals present in the body odor of individuals with illness that need to be detected to more accurately identify the presence of illness in an individual. But it is also important to remember, indications of a disease is not the same as being professionally diagnosed. Individual anomalies that can lead to inaccurate readings may still have illnesses that go undetected by the technology. Any indications or suspicions one may have should be confirmed by a medical professional, such as a doctor, to bolster accuracy. So why bother delving into such technology? Because not everyone has the financial ability to take the opinion of a medical professional. The key to healthcare is accessibility and affordability for all humans. The importance of early detection of certain illnesses can be vital in increasing the chance of successful treatment and diminishment of illness in communities, as individuals with positive tests for contagious illnesses can be quarantined off at an earlier stage, perhaps limiting the spread of the contagion. More importantly, in some cases, early detection can give one another chance to live.